that mic on?
Okay, welcome everyone. It's my great pleasure to open this union session that is going to focus on one of the most challenged coastal zones in the world, arguably the one we're right in the middle of here in New Orleans. So I'm just going to say a few introductory words. My name is Torbjörn Törnqvist. I'm a Tulane professor here locally, and I'm doing this on behalf of the conveners who are sitting here next to me. Mead Allison here in the middle, who's at Tulane and the Water Institute of the Gulf. Sam Bentley, who is at LSU, and Scott Hemmerling, who's hiding behind screens, who will introduce the speakers later on. Scott is also at the Water Institute of the Gulf. So the purpose of this session is to provide an overview of this tremendous environmental problem that we're facing in this region that centers on, staggering rates of coastal wetland loss and all the impacts, not just on the landscape, but also the humans. So we've brought together a list of speakers, which will of course be introduced later when they come up to the stage, that I think is a really exciting lineup. They cover different disciplines that range from the geosciences through ecology, engineering, to the social sciences, to really try to capture this very multidisciplinary and complex problem. They also represent both academia and agencies, both at the federal and the state level. And perhaps they also represent different viewpoints. This is a sometimes controversial problem that invites a lot of discussion, and I think that's one of the objectives of this session, to try to capture that. So just to give a little bit of brief context, this is a study that came out earlier this year that tried to measure the present-day rate of relative sea level rise in coastal Louisiana. All these data points represent point observations, and if you pull it all together, we find that, say, over the past decade, the rate of relative sea level rise in coastal Louisiana averages about 12 millimeters per year. And that puts us at about 4 times the global average. So what it means is that we see a lot of things happening in this region that we expect to see on a much larger scale worldwide later in this century, associated with further acceleration of the rate of global sea level rise. So these are problems that have been recognized for a long time. I should add that the wetland loss problem is caused by a variety of things, and sea level rise is just one aspect. What it has led to is that Louisiana has a state agency, the Coastal Protection and Restoration Authority, that is really entirely focused on these issues. And CPRA puts out a coastal master plan every 5 years. You could call it the IPCC report for Louisiana, if you will. And the most recent one just came out this year. So I'll show 2 slides here with predictions of future wetland loss under different scenarios, looking 50 years ahead. So everything in red is predicted loss if there's no action in terms of coastal restoration. If we go to the high scenario, which is really the scenario we are following right now, if you look at how climate is changing relative to projections, it starts looking like this. So this is obviously a tremendous problem. And there is a lot of thinking about possible solutions and things that can be done to mitigate these issues. The one that has probably drawn most attention in recent years is the idea to divert sediment back into the Mississippi Delta, because that sediment starvation is an important reason of the wetland loss that we're seeing. As you can imagine, plans like the one illustrated here are very complicated because they not only affect the landscape, they affect humans on a large scale. and they affect livelihoods. So those are important aspects that we also want to cover, and one that has gained a lot of attention in recent years is this small community in an isolated portion of the delta that is currently being relocated inland. It has been referred to as the first group of climate refugees in the United States. And it's probably just a precursor of things that will happen in the future on a much larger scale. So the speakers will cover many of these aspects, and I'm going to hand it over to Scott Hemmerling, who will introduce the first speaker.
So our first speaker is Bren Haase. Bren is the chief of the Planning and Research Division at Louisiana's Coastal Protection and Restoration Authority. And I'm going to keep the introduction short and sweet so we can get right to the presentations. And we will, if we have time at the end, we have a few minutes between speakers for questions. Otherwise, we will have 10 minutes or so after to bring the whole panel up and have discussion then.
Thank you, Scott. Appreciate that. And welcome to everybody. Good morning. Happy holidays. I was loading my presentation today and noticed the festive lights in the speaker ready room there, so I'm glad that the AGU is embracing the spirit of the holidays. It's a great time to be here. It's a great time to be in New Orleans. Imagine many of you have been here for a few days already, and hopefully you've been welcomed warmly, but if not, let me be the first to do so. Welcome to Louisiana and welcome to the city of New Orleans. I am Bren Haase. I work for the Coastal Protection and Restoration Authority. We are the state agency charged with dealing with many of the issues that we'll be discussing here today, and I want to talk with you today about our master plan for coastal Louisiana. So you've already seen one of these maps, or maps similar to this, and I'm glad to see that, because this really is the existential issue facing coastal Louisiana right now. It's a crisis that we're facing here in coastal Louisiana of regional, certainly national, and really even international proportions. We've lost almost 2,000 square miles of our coastal wetlands since just the 1930s. Much of that has had to do with our history of living along this coast and how we've derived ways to do so in a sort of a reliable manner. So coasts and deltas, as you are well aware, are very dynamic places, and we as humans certainly have distinct needs to reduce variability so that we can have predictability in terms of living safely in and around deltas and certainly making a living there. And so many of the things that we've done to manage our coast has resulted in some of the issues that have plagued us in the past, and you'll hear more about some of the issues that likely will face our coasts and our deltas as we move into the future, I think, with some other speakers here today. But assuming that we don't change how we're operating and how we're living and working along our coast, and as we look into the future, we don't anticipate those trends to change. So I should have pointed out, I guess, on that first map, the red on these maps represents land loss, the green represents land gain. And looking into the future, a prediction of what our landscape might look like 10 years from now, you can see the additional red on this map. This is red in addition, or land loss in addition to what was just previously shown. Over and above that, about 2,000 or so square miles of land loss. At year 10, looking out at year 20, you can see that we anticipate obviously losing more land. Year 30, 40, and looking out at year 50, you can see what one of the predictions for the future of our landscape might look like. This is that medium level scenario that Tor mentioned earlier. So this represents another 2,000 or so, or just over 2,000 or so square miles of land loss. But if you look at some of the higher rates of land loss that are plausible for our future, you could be doubling that, up to 4,000 or so square miles. This is immensely important, not just from an ecological perspective, but certainly to the people that, again, live and work along our coast, because as our landscape degrades, it impacts our communities and where we live as it relates to flooding, primarily caused by hurricanes and tropical storms. And so these maps here represent flood depths along our coast for about a 100-year event. You can see that the depths range from about 1 to 3 feet in the blues there, and then up to over 15 feet with the purples. This is what flooding might look like basically with the landscape that we have right now. If we take a look into the future and consider that potential degraded landscape, you can see what it might look like at year 10, here again at year 25. and then looking out 50 years into the future. And of course, you know, areas along the coast were predicted to experience much higher levels of flooding, and those floodwaters are expected to propagate much further inland, impacting those communities in and around the coast. Why is this important? Well, it's where we live. It's where I live. It's where many of us up here, I think, today live. There are over 2 million people that live south of the I-10 corridor along coastal Louisiana. It's where we work. It's where we make our living, as I referred to earlier. Coastal Louisiana is an economic driver for the state and for the region and even the nation. And obviously, I hope you've had a chance to experience some of the culture here in New Orleans. That culture is very intricately tied to our coast and the bounty and natural resources associated with that coast that it provides. So in recognition of this crisis, and really the watershed moment, if you will, was the hurricane season of 2005. You'll recall that that's the year that Hurricane Katrina hit the area that we're standing right now, and Hurricane Rita hit, of course, the southwest coast of Louisiana. It's really when the state, I think, finally understood that perhaps we weren't conducting our business in the best manner possible. We had an entity within government that was dealing primarily with ecosystem restoration, and it was really kind of on a piecemeal basis, and another entity within state government that was dealing with risk reduction or trying to protect citizens from flooding. And frankly, the two entities didn't really communicate, didn't know all that much about what each other were doing. And so it was certainly recognized during that year that these things are important to each other, and an integrated approach is really the way that the state needed to move forward. And so the organization that I work for, the Coastal Protection Restoration Authority, again, was formed, and one of our charges was to develop, implement, and enforce a comprehensive plan for coastal Louisiana that would integrate those two things that are very important to our coast. So I'm going to talk about our plans and some of our predictions for the future, but it's important to note that there's an awful lot going on in coastal Louisiana. Over the last 10 years or so that our organization has been in existence, about $20 billion has been secured for restoration and protection work along our coast. That's benefited, we've dredged about 120 million cubic yards of sediment to do things like build coastal wetlands, barrier islands, ridges, things of that nature. That's benefited over 36,000 acres of our coastal landscape. About 282 miles of levees have either been built or improved. Many of those we're sitting behind right here at this location today. And you see the number 60 there, that's really a little bit out of date. That's really pushing 65 or 70 miles of barrier islands or barrier shorelines have been restored just over the last 10 years or so. And there's an awful lot going on right now. As we speak, just north of us, there's sediment being dredged at the Bayou Bonfuca Marsh Creation Project. We're doing work on the Whiskey Island, which is a barrier island in Terrebonne Parish right now, and there's also work being done in the far southwestern corner of the state at Oyster Bayou. So there's a lot going on, a lot has occurred, and a lot's going on, and there's work occurring, of course, right now as we speak. But to get back to the plan a bit, we are in the third iteration of that plan. There have been 3 master plans since CPRA came about. First was in 2007, second was in 2012, and most recently this year, the 2017 master plan was approved. Why do we do a plan every 5 years? Well, we're required by law to do that. As we were formed and mandated to develop this plan, we were also required to update it every 5 years, and I think with good reason. Of course, as we know, the coast is a very, very dynamic place. It has it can change very rapidly, and certainly if we experience a major event like a Hurricane Katrina, we can have major changes in as little as 10 to 24 hours, of course. And so taking a look at our plan every 5 years allows us to update to those changes, adjust to those changes, adapt to those changes, and also, of course, as we do this work, we get better at what we do. Technology improves, and so it allows us to incorporate those changes into our updated plans. I think it'd be foolish to have a plan today and assume that plan developed today would be appropriate at year 50 years from now. Of course, the plan is all those things you see here. It is built on world-class science and engineering. It incorporates extensive public review as well, and it advances that comprehensive approach that I mentioned between ecosystem restoration and risk reduction. And it identifies benefits that will pay off for us, hopefully in the short term, but also in the long term as well. It does take a bit of a long-term view. To me, it really boils down to a couple of things, though, when people ask me what the master plan is. It's a way to make some really hard decisions about the future of coastal Louisiana and to try to make decisions about what are the best investments to make in our coast for the most good for our coast. And then at the end of the day, it's a list of priorities. It's a list of things that we believe in the state of Louisiana that we need to implement to try to achieve our goals. And so those objectives are listed here. Of course, we want to protect our citizens from flooding, as we've alluded to already. We want to harness the natural processes that have built South Louisiana, Southeast Louisiana in particular, in the first place. We want to provide coastal habitats to important commercial and recreational species, of course. I mentioned the cultural heritage as well. Again, that's intricately tied with our coast. We want to be able to preserve our coast and preserve that unique and valued heritage that we've got. And Louisiana's coast also is very much a working coast. I think it's unique among many places, certainly in the country, that this isn't a coast that we simply visit and go to New Orleans and have a hurricane, or perhaps go take a fishing trip or a birding trip or something along those lines. Those are all great things to do, and we encourage them. But it is a place where we certainly live and work. It's where we make our living. So what are some of the differences? I mentioned the various iterations of the plan. What are some of the differences between 2012 and 2017? Well, there are a few. We really, we mentioned the science and engineering already that goes behind the 2012 plan, and we really took a hard look following the 2012 to ask ourselves some tough questions, like what are some of the things we'd improve? What would we do differently? What would we do better? And we did a concerted effort to improve many of the tools that were used, many of the data collection efforts and so forth to improve that for 2017. We at CPRA don't think we have all the right ideas for restoring our coast and protecting our citizens, and so we put a public call out, two actually public calls out for new ideas to be considered as part of the 2017 plan. Got a tremendous response from those, and many of those projects indeed are included as part of the 2017 plan. There's an increased focus on flood risk reduction and resilience, and you see that in a more refined, I guess, and robustly described non-structural risk reduction plan that I'll touch on here in a bit. There's an increased emphasis on the communities. Again, why are we doing this? Well, it's for the people of our state, the people of our coast. And you'll see a much broader discussion, or directed, I guess, discussion related to how these issues are affecting our communities and the people along our coast. Outreach and engagement was expanded, and because of the settlement associated with the BP oil spill, we had a little clarity on funding and when dollars might come to the state. And I'll talk about funding in a bit, but I'll tell you we don't have all the funding that we need, which is probably a universal statement for all of us, but nonetheless it's true. But the settlement gave us a little bit of clarity related to when we think funding might come to the state, which affects, of course, how and when we can implement parts of the plan. So this is a cartoon really of just kind of the plan development process. It really starts with the projects. Those projects are evaluated with some of those tools that I mentioned, and then that output from those evaluations are organized and scrutinized, if you will, through something that we call the planning tool, and I'll touch on that in a bit. So let's start with the projects. There were about 209 projects that were evaluated as part of the development of the 2017 plan. There were 135 restoration projects, and hopefully you can see the various types there, but there are sediment diversions, hydrologic restoration projects, marsh creation, bank stabilization, and a number of others of those projects. 135 of those were evaluated. There were 54 non-structural projects evaluated, and these are things that we don't typically consider or haven't in the past typically considered as sort of risk reduction or hurricane protection type features. So these are things like flood proofing of non-residential structures, elevations of homes, and voluntary acquisitions of residences as well, where that may be deemed necessary. Then there were 20 structural protection projects that were evaluated as well, and these are things that are a little bit more traditional that we typically think of as risk reduction features: levees, floodgates, flood walls, those kind of things. Just to give you an idea of the demand for this kind of work in coastal Louisiana, these are, again, just the 209 projects that we evaluated. If you put a price tag on those in today's dollars, you'd be looking at about $150 billion worth of work. We don't think it's realistic that Louisiana is going to have $150 billion over the next 50 years or so to implement all these projects. And so this really gets back to sort of what is the master plan, and it's a way to make some of those tough decisions about what are the right investments for the coast. How do you whittle $150 billion worth of good projects down to the appropriate ones that you think fit within what is, what may be a realistic budget? And I'll touch on that in a bit. Predictive models. So there were a couple of aspects to the tools here used to evaluate these projects. First is the integrated compartment model, and these are really where we ask ourselves, how do projects or does a project or a suite of projects impact things like where water moves, what's the salinity of that water, what happens to the vegetation, are we accreting land, are we eroding land, how does sediment move, what happens to fish and wildlife, and those kind of things. And then the second part of this area is the surge, waves, and risk assessment models, where we do, again, ask ourselves, well, how do these projects affect storm surges and waves? And then how does that translate into risk, hopefully reduce risk along our coast? And all of this is being evaluated over a range of potential environmental scenarios into the future. And let me delve into that just a little bit more. So, the predictions for the future that I showed you earlier on those maps really related specifically to land loss and how environmental factors might impact that land loss into the future. And so you see some of those environmental factors listed here: precipitation, evapotranspiration, sea level rise, storm frequency, storm intensity, and subsidence, of course, as well. And one thing we know is we don't know what tomorrow will bring. We can't predict the future with a high degree of certainty, right? And so these things are all, frankly, unknowns. But we do have an idea of the way things might be trending. And again, I think you'll hear a lot more about that from some of the other speakers. But all of these things relate to whether or not we may experience a low rate of land loss into the future, that something in the middle, or a medium rate of land loss into the future, or a high rate of land loss into the future. And so our goal was to develop a plan to select projects that were robust across a range of potential futures, so that we're making the best investments, again, for the state of Louisiana and for our coast. You'll find, if you've taken a look at the master plan, that we did formulate the plan assuming that we would experience that high rate of land loss for reasons that Tor alluded to earlier. That seems to be kind of where we're tracking right now. So. In addition to the fact that if we experience something less than a high rate of land loss into the future, hopefully we've made good investments. And keep in mind, we're updating the plan every 5 years so that we can adjust to that as well. So give you a little bit of an idea about the low, medium, and high. You've already seen this actually, so I'll go through it relatively quickly. But this is what the landscape might look like 50 years from now under that low scenario, the medium scenario, and then this is the one that you've seen earlier already, again, under that high scenario. And this represents, again, about another little over 4,000 square miles of land gone from the state of Louisiana. So let's talk about the planning tool a little bit. As you might imagine, from all of the predictive models and the suite of tools that you use, there's a tremendous amount of output that can be difficult to organize and frankly understand. And so the planning tool helps us do that. And it really helps us informs a selection of projects, if you will, based on two primary factors. And you see those here: how well do projects reduce risk, and how well do they help build or maintain land along coastal Louisiana. So you see those listed up here on the top left of this slide, but there are also some other things that are really important to us. One of those is some real constraints. Again, I mentioned that if we implemented all 209 of those projects earlier, that you're looking at about $150 billion worth of projects in today's dollars. Like most of us probably in this room, finances are a real constraint in what it is that we can do and what we think we can accomplish, and so that was used as a constraint for developing the plan as well. We think something on the order of that $50 billion range is something that's plausible for the state of Louisiana to be able to expend to implement this plan over the next 50 years or so, and so funding it, again, is a constraint. We hear sometimes that the budget is $50 billion, and that's true in one sense, but that's not what we're shooting for. It's not necessarily aspirational. Certainly, we could do more with more, but we want to be realistic with our citizens and make sure that we're not providing information that perhaps is not as truthful as it could be. We want our citizens to be well informed and be able to make good decisions for themselves. And then there's some other natural resource constraints. Sediment obviously is paramount among those. Is there enough sediment to do what we want to do? And there are these other things that are important to us that we list as metrics, of course. And so if you're interested in how the plan might impact traditional fishing communities or navigation or a particular species of fish or wildlife, we can look at those things as well to help inform, again, what ultimately the plan looks like. So that's a little bit of the technical side of things, and certainly that's very important to the master plan, but there's also a real need to be responsive to our citizens and to our community needs. And so I mentioned earlier there really was an unprecedented effort to ensure that folks were included and understood the process, the decisions that have been made throughout the planning of the development of the master plan. And you see a number of those groups that assisted us throughout the process. I'll not go through each of these, but just know that this represents over about 150 or so opportunities for us to have conversations about the plan, hear from concerned citizens, and answer questions and respond to those concerns. So some key decision points related to the plan. Excuse me. I mentioned the funding constraint and that $50 billion already, and I've already mentioned really that we think some of those dollars may come to the state sooner rather than later as a result of the settlement with the BP oil spill. You might ask yourself, we've got sort of these restoration projects and risk reduction projects, so how do you know how much to spend on each? Well, we did some sensitivity analysis using some of our tools, and it turns out that roughly that 50-50 split is about the sweet spot. It's about where it needs to be, and so there's an equal split among that. Within that $50 billion, there's 25 assumed to be spent on ecosystem restoration and 25 billion assumed to be spent on risk reduction as part of this plan. I already mentioned that the plan was formulated on that high scenario. Again, we think that's a conservative approach. If we experience something less than that, we hopefully are well positioned and have made good investments to adjust to that. But it is on that high end of the range, which is seems to be where things are headed. In terms of short-term and long-term results and benefits, we know obviously we're in a crisis and we need to do some things to benefit our coast today, right now. But we also know that we need to make wise investments so that we're not the only ones that benefit, but our children and grandchildren do as well. And as a result of, again, that outreach effort that I mentioned earlier, there was some real changes made to the plan as a result of that public input. So at the end of the day, the project looks, or the plan looks like this. There are 124 projects as part of the plan. Each of the shapes you see here, thank you, represents one of those, and I'll not go through each of those, but we think that this plan can reduce flood damages over a 50-year period by about $150 billion and result in land in coastal Louisiana of about 802 square miles that we otherwise would not have. So just a closer look out west. Again, whoa. You get to see the presentation in reverse now. Anyway, this is just a closer look in the southwestern part of the state and what some of the projects look like there. A lot of marsh creation projects, hydrologic restoration projects. You see some non-structural and structural risk reduction projects, shoreline protection, and so forth. As we start to move into the central part of the state, as we move further to the east, of course we have the Atchafalaya River here, and so you start to see some of the river diversions come into play, Barrier Islands as well. And then as we move further to the east, of course, we've got the Mississippi River, which is right behind me here, and so you start to see some of the efforts to reconnect the river with its deltaic plain there, and some of the other similar types of projects as well. 32 non-structural risk reduction projects were selected. Each of these shapes represents one of those or an area where we think that's a good risk reduction measure. This is just a breakdown of the project types between restoration and risk reduction, and you can see the dollar amounts and project types associated with each of those. Again, it's about it is a 50-50 split. And then if we look again at some of these landscape prediction maps into the future, what you see here is, again, that future without action. This is looking out at year 30. We jumped ahead a little bit from what we've done in the past. This is without the plan in place. Then you look at year 30 with the plan in place, and you start to see some more of those greens. And this is a result of the projects coming online as part of the master plan. Look out at year 50, again, without the plan in place, and then at year 50 with the plan in place. And again, you start to see some of those, some of that land that otherwise wouldn't be there, again, in the amount of about 802 square miles. And this, again, affects flood depths. And so we'll look at the medium scenario at year 25 without the plan in place. And then we'll look at year 25 with the plan in place. And there is a difference there. It's difficult to see, but I'll show you the difference map here. So those greens and blues represent reduced flood depths along our coast as a result of implementation of the plan. And then we'll do the same thing for year 50. This is without the plan in place. With the plan in place, then you see the difference map here. And so by year 50, the annual reduction in expected damages is about $8.3 billion. So what's all this mean? Well, it provides a wide variety, frankly, and a diversity of projects for coastal Louisiana. There was a time in Louisiana when we were really having a lot of discussions, and some might say arguments about what are the right projects to do. Do we do just dredging or just diversions? Do we do just barrier islands or just marsh creation? And I think we've overcome that. I think we're in a place now where we understand that it's really an all people on deck kind of a situation right now, and we can't afford to leave any stone unturned, as it were. Of course, we build and sustain land, again, 802 square miles of land or so that we wouldn't otherwise have. We reduce risk to the tune of about $150 billion. There's some real benefits to the ecosystem. I didn't really touch on this in great detail, but by and large, our fish and wildlife resources, vegetation and so forth, fare better over the 50 years with the plan in place than they do without it. And it gives us some time to prepare and adapt. So I mentioned, not in great detail, I guess, but hopefully you understood that obviously there's a lot of uncertainty about the future. This is a 50-year plan. As we get out into year 30, 40, and 50, we really don't have a very good idea, frankly, of what that future may hold. But we do have a good idea of what may occur over the next 4 or 5 years, which is sort of the time period in which we'll be reevaluating this plan, looking at what future scenarios may hold, and adjusting to those. And so this plan does give us some time to prepare and adapt. It's built in automatically because we have to update the plan every 5 years. And then lastly, and this was touched on earlier, we believe this does provide some economic benefit and really an exportable commodity for the state of Louisiana. So if Louisiana really is the canary in the coal mine, and we're dealing with some of these issues before many other places within the country and in the world are going to be dealing with those, we're developing this expertise, we're developing this skill set that ultimately may be able to assist other people in other parts of the country and the world. So, getting low on time, I'll wrap it up here. If you're interested in learning more about the master plan, first of all, I'll be around a little bit this afternoon, so feel free to come up and talk to me. But there's more information than you could ever care to look at our website, coastal.la.gov. You can get as far into the weeds as you would like in some of the outputs, technical analyses, and other aspects of the plan. And then lastly, there's an interactive tool on our website, the Master Plan Data Viewer. This is something we're pretty proud of. I think it's a very useful tool. You can get on here if you're interested in project information. You can click on a project in an interactive manner and a mapping sort of paradigm and learn about those projects. You can type in your address if you live in coastal Louisiana, and you can see what your flood risk is today, what it might be 25 or 50 years into the future, both with and without the plan in place as well. So it's a good place to get a lot of good information about the plan and about coastal Louisiana. And with that, I don't know if we're taking questions now or if we're going to wait till the end. If we have some time, I'm happy to answer some questions. So looks like we do. Okay. Is there a question? Oh, sorry, I didn't see. Yes. You, sir, in the blazer. Nope. Areas that are, I'm sorry, I didn't hear you. Areas that exist today that are like what we would like them to be? Well, yeah, I mean, I think if you ask most of the citizens in coastal Louisiana what they would like the coast to look like 50 years from now, they would say we want it to look like it does today. Which is, you know, obviously we don't think is realistic. And so one of the things that we're trying to overcome as we develop this plan and work with our stakeholders is an understanding that the coast of the future, whether we implement this plan or not, is going to be very, very different than the coast of today. In terms of sort of, you know, showpiece, I guess, areas of the coast, you know, I think you know, the Wax Lake and the Atchafalaya Delta are areas that, you know, have shown that there are definitely some things that can be done. We have some tools in the toolbox. One of the things we have in Louisiana, of course, is our major rivers that can be a tremendous benefit to help us deal with some of these issues that perhaps other places in the country don't have the luxury of possessing, frankly. Thank you. Thanks, Bren.
Thank you, Bren. Our next speaker is Liviu Giosan, an associate scientist from Woods Hole Oceanographic Institute, and he'll be speaking on survival of deltas under anthropogenic global changes.
Till they prepare the talk, let me start. My name is Liviu Giosan. I'm a geoscientist with Woods Hole Oceanographic Institution. And I'd like to start by thanking for the invitation. And I'm going to give the big picture, global picture about the situation of deltas around the world. And I want to start by saying that Mississippi is lucky in some ways, because it's in a developed country and money could be raised for restoration. And it also possesses a lot of brilliant scientists, some of them in the room, that could help with this problem. Okay, so how do I move it? Oh, with this? Okay. So let me start by saying, let's see. Doesn't work. Coastal protection is going to be one of the biggest problems of climate change, and deltas are the vast coastal areas that will be most affected because they are dynamic, transient, and they collide with our wish for stability and permanence. And you could see a natural delta and below a delta that you wouldn't say that's a delta. That's a big city. Next. Okay. That's how a delta should look. Very expansive, productive, biodiverse, lowland. And that's how they shouldn't look. First was from a healthy delta in the Danube, and this is from the Mississippi. And the ugly, we were shown the ugly by Bren. That's what could be lost. Deltas are very complex, yeah? How do we deal with this problem? And they are data poor because look at their complexity as seen from satellite, that look at the scale. Some of them could span 100 by 100 kilometers, 200 by 200 kilometers. So it's vast. How do you collect data in these? So we're faced with this problem. We should keep it simple. So I'm going to try to keep it simple and see the commonality of all deltas around the world. Keeping it simple, we took a few years ago a bathtub mass balance, bathtub approach, saying like the sea level rises, like in a bathtub, how much we will lose. There are big assumptions behind these graphs, so I'm going to explain it because it's going to return in my talk. What we have there in that graph, we have the minimum sediment need for 1 meter sea level rise in the next 100 years. And the best scenario for sediment, maximum sediment that we can get down the river in 100 years. And we ignore that most of the rivers are dammed. So you could see here that most of the large deltas, the big bubbles, and medium-sized deltas, the intermediate bubbles, are in the red zone. So we do not have, even in the best case scenario, enough sediment to keep them as they are today. So undergrowing sediment deficits and accelerated sea level rise, simple mass balance indicates that major deltas are unstable. Natural sediment discharge, how can we get to this? We have 100 years at most in most deltas of measurement of natural sediment discharge. But this natural sediment discharge is in quotes because it varies. It's not stationary. How all those large deltas might be legacy deltas because before we put dams on rivers, we had agriculture in place, and that increased the sediment discharge. This is a case in Danube Delta where we're reconstructing the volume of the delta. And what you see with yellow masks are deltas built in the last 400 years just because of deforestation. So those large deltas that are around the world, many of them and large part of them are legacy. Even in the Mississippi, the bird foot might be a legacy delta. Climate effects. Again, sediment discharge is not stationary. This is from a presentation that you should attend later in the week from an upcoming study that shows that flood, so our sediment that builds delta comes during floods mostly. Floods are non-stationary, and this is a reconstruction that goes beyond our measurement of 100 years to year 1700s, and we could see that variability is non-stationary and it has a rhythm on it that's driven by climate. That's something that's not yet taken into account. Damming, the same graph, and we put most of the rivers are dammed, and it's common to have 50% of their sediment discharge lost already, trapping behind dams. You see that the red zone increased. Most deltas that are large and intermediate cannot survive as they are in the future, in the next 100 years. If we put at 90%, only very few small deltas could survive, have enough sediment. Now, what is to be done? Those who are old enough, they know this. It's a famous question. And let's hope that our answer is much simpler and the results much better than in this case. So my answer to this is that heavily dammed rivers carry less sediment, more efficient use of what we have, we can help mitigate those lands. So how does a delta build? This is an example with Ganges Brahmaputra. You could see, if you build it, you need a lot more sediment that goes in progradation toward the ocean than in keeping the delta plane above the water. So that sediment that goes to prograde the delta could be used to instead accrete on the delta plane. This is from a study that it's in Works. We looked, as a geologist, I tried to compile data from these rivers, and you could see this is how much sediment goes into progradation, how much into accretion on a logarithmic scale. I draw your attention to the logarithmic scale. So you could see for accretion in natural conditions in geological history, we use at most 30% of the sediment that the river gives us. And the average is around 10%. Now, if we put how much we lost, again on the logarithmic scale, we are somewhere an order of magnitude lower in most of these deltas of sediment availability. But still, we still have sediment that could go to the accretion of the delta plane. What types of reconstructions we could do? One has been presented by Bren, and they will be presented in the session today, is building sediment diversion and build crevice plays or internal subdeltas. The key need here was taught that is sand, because you need to build a framework of channels that support the marshes. And that's an iconic figure from 2009 from a study where they took the figure from Wax Lake and put it added to the sediment diversion. Well, a recent study has shown that mud has a lot to help here. Yeah, so when you do these, most of the crevice structure architecture is mud. It needs the framework from sands, but muds help. Or we could divert completely the course of the river and build new deltas. That's been happening for the Wax Lake and Atchafalaya, but I want to draw your attention to an older example, the Brazos Delta in the 30s. It was diverted from the port of Freeport that was shoaling, and a new delta was built. So it could be done. Also, there is a big difference between rebuilding, growing a new delta, and maintaining one. So maintaining the delta plane, it's a different story. So if we look at how deltas evolve from a juvenile stage to a mature stage, we see that we're losing channels. So this is an example from the Danube Delta 1 lobe, mapped since 1830, and you could see that by 2000 we have about 5 mouths. Oops, I can go back. Okay. In its history, in its juvenile stage, we reached at some points 56 mouths. So we're losing channel. In this case, we're losing because they are blocked by waves and infilled from the back. But there are many reasons that we're losing channel. We're losing connectivity. If we lose channels, we lose the ability to spread the sediment on the delta plane. So one solution for maintenance is marsh magic. Yeah? We sustain the delta marshes on the delta plane. So now the same graph, but we move with 50% organic accretion from the marshes. We see that we are already, this is 90%. We see this is an exaggerated case. We cannot maintain a delta only with organic accretion. But we could be somewhere in between. If we send mud that keeps those marshes healthy, we can still have a large proportion of deltas being healthier than they are without. So how can we do this? We return to a juvenile stage. We do channeling on the delta and spread in a natural way sediments, increase the connectivity. And this has been done. In the Danube Delta, this has been done in the 1950s without having this goal in mind. They wanted to dig shallow channels for fishing to access the deltas. And you can see the channels in red, the channel network. Well, we studied that region, and we see that the accretion rates are well above the sea level rise there. And they just skim the surface of the water during floods. Very little mud that just helps them stay healthy. Now, I'm not going to talk about this story, but in some cases, we will have to abandon deltas. There's not, depending on the finances. There might be a country that cannot keep a delta as it is now. So that's an example of how a delta, when in its abandonment stage, can evolve by coastal erosion and actually build healthy marshes and barrier islands downstream. And this is like a giant sand engine, which is a solution for coastal protection applied in the Netherlands. Deltas could be considered, in this case, as giant sand engines. So that the photographs show where they actually dredge sand and put it on the coast and left it. And you can see it spreads around the coast. The coast stays more in equilibrium, erodes less, and so on. Now, we're heading toward the future that we'll have to have design deltas as the only way to preserve them. So understanding delta paleomorphodynamics as examples I presented here, provides a framework to design flexible maintenance strategies, evaluate success, and design healthy deltas of the future. And Mississippi leads the way because we are far away in thinking about these things. And as Bren noticed, this could be exported. Key need for deltas around the world. We need to address lack of homogeneity in the delta plane. Parts of it survive, parts of it are not healthy. And that's a big problem because deltas are big landscapes. We need field data, and I repeat like my friend before that said what is to do. He also said learn, learn, learn. I would say field data, field data, field data. We're using models, but the results from the models are as good as the data that go in the models. And we need more field data around the world. And we need to employ remote sensing, monitoring from space, because that could revolutionize data collection around the world. And thank you very much.
Are there any questions? Okay.
Thank you. It's on this one. Is it on this one? Yep.
Give me a glass of water, please.
So our next speaker is John Day, a professor emeritus in the Department of Oceanography and Coastal Sciences at Louisiana State University.
Yes, please. Okay, well, thank you. I'm going to talk about what I see as a number of important constraints on what we can and can't do in the Mississippi Delta, and it's based on an understanding of deltas worldwide. How do I change this? Oh, yeah. Okay. So what I'm, actually I want to go back, look at the title. Yeah, I'm going to talk about shifting baselines, diminishing resilience, and growing non-sustainability. So I'll talk about natural and human development in the Mississippi Delta during a time of stable, predictable conditions. Human activity altered this and led to shifting baselines and collapse of the delta, which is ongoing. And management has become very energy intensive, which probably can't be sustained. Climate change will make delta restoration more challenging, and resource scarcity, especially energy, will severely limit options for management. And the delta will change dramatically, and society will have to adjust as the ability to control nature diminishes. And I think a sustainable delta is outside of the boundaries of the current coastal master plan, but this is a living document, so it can change over time. Okay. Yeah, and this is everybody's seen this famous delta lobe about how the delta developed over time, but I think what people don't think about as that the human society, for most of the emerged at the same time. So as the delta lobes formed, Native American populations moved into the delta basically as it was forming and established there. And if you look at across the coast, you see there are hundreds and even thousands of these Native American mounds and shell midden sites. So they occupied the delta as it was growing and built, you know, and made their livelihoods there. So the human situation and the delta, the natural situation, occurred at the same time. This is what I see is all of this development of the delta, both the natural system and the human system that existed there, occurred during a period of stable, predictable conditions. And Liviu was one of the first ones who told me about this. There was a stable sea level for the last several thousand years, relatively stable, predictable inputs from the basin. Within a range, it varied from year to year, but it was predictable, and it was repeatable. These were extremely open systems with a high degree of interaction among river, delta, and coastal ocean. All of this has changed. And we'll talk about that. And so we're living in a very different situation now than existed during the major development of several thousand years. Climate's a big deal, and we all talk about it, so I'll review this very quickly. Sea level is rising. It's between 3 and 4 millimeters a year, and the current rate is below the lowest model predictions for the Coastal Master Plan. It's predicted to rise by 1 to 2 meters in this century, and it's going to keep rising. That's the important thing. Over the coming centuries, it's going to rise by several more meters. And so how long do we plan for? Just for 50 years and build a system that will survive then, but not afterwards. Hurricanes are a big issue, we know that the projections are that the stronger hurricanes will become more frequent. Intense weather events like occurred in Hurricane Harvey over in Houston, where 50 inches of rain occurred in 3 days. And if you've got a system that needs pumping, it won't work on this kind of event. There's been a reduction in sediment input, as Liviu said, and this paper by projecting peak increases in the peak discharge of the Mississippi River by from 10 to 60%. At 60%, you're probably looking at a situation where the Mississippi River and tributaries flood control system on the lower river begins to fail. So we've got to face up to these things. Well, Liviu talked all about this, that the big deltas, including the Mississippi, are oversized. So I'll pass on by this. And this is the famous paper by Blum and Roberts, where they said if we don't do anything with a meter of sea level rise by 2100, the coast will look like that, would essentially be gone. And so that's all basically due to human activity, changing those 3 conditions that I talked about earlier. And if you look at this is one of the outputs of the 2017 master plan, and it basically looks pretty much like Blum and Roberts' projection. The coast disappears, and you have these narrow distributary ridges, and I don't think many people would think that living along those distributary ridges without a delta around them is really possible. And this is another representation of what Brent showed, that with the master plan, the coastal marshes still largely disappear. And you have these exposed natural levee ridges, and the projection is that you would put a good many fresh marshes in the interior basins. That's accomplished by building levees, barriers across the basins, the Pontchartrain, Barataria, and Terrebonne basins. So you got a situation where we're putting in barriers to protect the inner parts of the delta in a situation where sea level is rising and where intense weather events are going to become more probable. And, people talk about we're getting 1,000-year floods every year. Well, if sea level rises, and this areas would have to go under pump, that's not possible at the scale. It's just, I think, unaffordable. So we're facing some really dire situations in the future. Tesla et al. Published this paper in Science about the impacts of energy scarcity on deltas worldwide, because especially in developed countries, the management systems that are being developed are highly energy intensive, and they concluded that you can see there up at the top is the current risk of non-sustainable outcomes as opposed to future down the road risk. And you can see that the risk of non-sustainable outcomes will be higher for systems with energy-intensive coastal management. And they specifically pointed out the Rhone and Mississippi deltas. So the risk of non-sustainable outcomes for the Mississippi would go up by a factor of 4 to 8 due to mostly due to increasing energy costs. And this is a study that we just completed. My last student made a model based on Jim Morris's marsh elevation model and added into it scenarios for marsh creation. The model creates a space that has to be filled if the marsh is going to survive, and it could be filled by a natural process like a diversion or by dredging sediments and pumping into them. And so if we look, shit, what happened? No, go back. Yeah, so basically what this is saying, these are sea level rise scenarios, and these are the ones that are basically used in the Coastal Master Plan, one being basically the current rate up to about 1.87 meters. And on this scale is oil price scenarios from no change, low, medium, central, and high. And all of these are from models in the literature. It's not something we sort of speculated about. And so in an energy-intensive process like marsh creation using slurried sediments that are being pumped often tens of kilometers, as you get further, you have to pump further and further, it costs more and more, and as sea level rises, it costs more and more because you have more accommodation space to fill. And in sort of the worst case scenarios without a diversion, the cost of building a unit area of coastal marshes based on this model could go up by a factor of 8. And at that point, it probably becomes unaffordable. And several people talked about the crevasses, and crevasses in the Mississippi Delta, these little sort of prints of a crevasse are based on the actual size of crevasses that are occurred along the Mississippi River. And this is just a few of the crevasses that have been documented along the Mississippi River and tributaries. And these things basically form a continuous overlapping series of crevasse plays, and that's what maintain the natural levee and also wetlands in the coast. I mean, in the wetlands themselves, and so let me go back here. So perhaps we're going to need to think about taking a different approach from very, very expensive diversion projects that cost between $1 and $2 billion to more diversions. More crevasses operated in a much more efficient way, maybe by degrading levees and rebuilding them, and rather than building these very expensive structures, because they may become so expensive it would limit the ability to implement the master plan. And another thing, in a book we just published with me and Jory Erdman, who is in the architecture department, were editors of a book that follows up on our earlier book, which was called The Cess. And they envision a New Orleans where you dredge from the lake bottom, build a buffer of cypress trees here that are wide enough to significantly lower waves on hurricane surge, and then create a series of polders, in effect, within the city of New Orleans, and one by one build them, fill them in, and let people move there and start raising the city. Because maintaining areas below sea level in this scenario of increasing energy prices and growing climate impacts is going to become more and more difficult. And we may be looking at a catastrophic failure of New Orleans. And so here's a cross-section. So you build a buffer of cypress, maintain the salinity with fresh water from the river, and protecting the dikes, raise the level, as was done in Lakeview, to build a high enough area, say at least 5 meters above sea level, and then begin to create polders in the delta and fill them in so that people can live there. And we did some estimates of maybe you could build, for $300 million, you could build a square mile of raised lands that people could then move to. Okay, so summary. Climate change will impact the delta strongly due to all these facts, all of these factors, and meeting climate goals, if possible, will cause profound changes in society and the economy. Energy scarcity will limit options for sustainable management of the delta, An energy-intensive approach will become increasingly unaffordable. Continuing ecosystem degradation will impact the natural and social systems. In other words, storm buffers, fisheries, and human activities will interact with these megatrends in a synergistic way to make these problems worse. Increasing river discharge will threaten the river flood control system, and I would, maybe we need to use multiple outlets that would provide both flood relief and wetland creation at the same time. And there are a number of examples along the river where this is documented. Ecological engineering, where energies of nature are primarily used, is a sustainable approach to coastal management, and I think humans will have to adjust to this growing variability, and our ability to control nature will diminish. And I think living below sea level will become increasingly untenable, and that's why this suggestion of raising large parts of New Orleans, and the recognition, I think, by everybody that the current system is inherently unsustainable. Okay, thank you.
If anyone has any questions?
We have a question here.
We're supposed to use the mic?
Oh.
Hey, John, thanks very much for that. I really appreciated your perspective of New Orleans, of trying to raise the city, but we certainly face this problem in many deltas where we have many people living below sea level. And yes, it's a great idea to try to raise these elevations, but there are a lot of social implications. You can't just displace people immediately. So as scientists, what are the best ways for us to inform and to try to advise mechanisms so that we can raise land levels while people are still living in those areas?
Well, in the book that I just talked about that we published, Craig Colton and someone else actually wrote about examples from around the world where land has been raised, and so it can be done. Is that answering the question?
Were the people displaced while they were doing these elevation gain practices?
Yeah, I'm sorry, I can't hear you.
Were the people displaced while they were doing these land elevation practices? What happened to the people that are currently living in those areas?
In some cases, they just said we have to raise the land. Like in Galveston, after the storm, they raised the land, and then it was the people's responsibility to come back and rebuild their houses.
Thank you.
Okay, thank you.
Thank you. Our next speaker is Barb Kleiss. She's the past director of the Mississippi River Science and Technology Program with the U.S. Army Corps of Engineers.
Good morning. So this morning, I am going to give some examples specifically from Louisiana, but as the other speakers have mentioned, I think some of the issues and constraints that we mentioned may also have bearing in many other places around the globe. First, I'd like to recognize my co-authors. Gary Brown is a hydraulic and sediment modeler from the Engineering Research and Development Center up in Vicksburg, who does an outstanding job, and then Leonard Schaubman, who currently works for Resources for the Future, and has completed a report recently on the permitting process involved with some of the restoration issues. There's several different types of restoration issues that we could talk about, but like others, I'm going to focus on the two large diversions that are currently being considered for permitting. One is Mid-Barataria, which has a maximum proposed diversion rate of about 75,000 CFS or 2,100 cubic meters per second, and Mid-Breton at 35,000 CFS or right at about 1,000 cubic meters per second. I also want to use this slide to give us a sense of scale. This distance right here between head of passes and the end of Southwest Pass is about 26 miles or a little over 40 kilometers. So you can see that these estuaries are quite large, maybe as much as 50 by 35 miles, and again 25 by 40. So we're talking about large estuary systems. Over the past 5 years, the Corps of Engineers has worked with the Bren's office at the Coastal Protection Restoration area, as well as the Water Institute of the Gulf, to attack some of the scientific constraints. And we've made a lot of progress, but of course, as always the case, as usual the case, some of the research has indicated areas that need more information. And one of those you've heard referred to several times is subsidence. Subsidence is a factor in every estimate that we use. Every indication of the benefit of a project, the success of the project, the viability of the project is dependent upon subsidence rates. And we actually developed a subsidence surface for the project area, which is probably, in my knowledge, the first time that a variable surface has ever been used in numerical modeling for such a large area in the United States. And so this was a significant advance, but then you have to understand something about the underlying data. This single orange star represents the one NOAA station, NOAA tide station, that has a long enough period of record to be used for subsidence in this area. If you look at the yellow dots, we have some additional Corps of Engineers tide gauge stations, and Will Beach has just put together an analysis, an updated analysis of those. And then Nainhouse has gone farther just recently and looked at CRIM sites. And these are great. They're a little bit more density, but the data for this is from the last 6 to 10 years, primarily because these stations were destroyed during Katrina and had to be built up. And then in terms of more detailed subsidence, Mead and Tor and others have been working with us to have a subsidence superstation to understand more. But you can see we're basing a lot of decisions on a very scattered and very sparse data set. Another issue is that these diversions are a lot of water. 75,000 CFS rolls off the tongue pretty easily, but in fact that is the same as the average flow of the Missouri River when it's not in flood stage. So when we now have subsiding land surface, but we also have water on top of it. And 75,000 CFS is enough in a shallow estuary, marsh area, to actually increase or pile up water. And so you can see from this model result that the area close to the diversion, the orange is about a 1 meter increase in water elevation, but even way out here, the royal blues are indicating 10 to 20 centimeters. So one of the things that we need to understand is what is the effect of long-term, because under some operation schemes, these will be operating as much as a third of the year, of long-term increase in inundation. Plants need access to root oxygen. They also need photosynthetic surface. What is the impacts on plants? And we have two modeling systems, one which assumes that the habitats, the plant species will switch to fresher water systems and continue to develop wetlands, but another based on Spartina patens that indicates that there's a possibility that the decrease in productivity, whereas there's land being built close to the diversion, the areas that are inundated but not close enough to receive benefits from mineral sediments might actually cause a net loss of wetland over a 50-year lifespan. Now, as most things, the truth is probably somewhere in the middle, but the answer to that question is a fairly important need for us to understand. Additionally, we have changes in salinity from that much water. The upper diagram is a April to June average salinity without project. The blue is less than 1.5 parts per thousand, but the yellow is 4 to 10. And this is what happens when the Breton Sound diversion operates, and this is Barataria, and you can see the increase of blue. So those salinity changes are a different change that in addition to inundation for the plants, but that also affects other organisms such as fisheries, marine mammals. And some people would lead these or categorize these scientific constraints as irreducible uncertainties. And it's not because they're impossible to understand, but it's because they're very complex, and all of the speakers have noted the complexity of it. But they're also making predictions about what will happen 50 or 100 years into the future that are difficult to test in the short run, and we have little financing and little ability within current permitting constraints to be able to address some of those uncertainties. So how does this fit into the social component? You see that increases in water depth in some cases, in some communities. If you're in a community that has a limited levee, then protecting the community, then those increases in water levels are something that might be of concern. Whether they are or not, they are certainly of a perceived concern. There's perceived concerns about increased nutrients that we have to address with the public. And then this illustration, this blue, light blue color, if you were to zoom in on that, what you would see is literally thousands of small 25 to 50 acre oyster leases. Now, in 2002, the Louisiana Supreme Court passed made a law that basically holds state and federal governments were held harmless for damaging oyster leases for the purposes of restoration. So it's not that we can't do anything, but this is just representative of the public interest in these types of activities. And one of the things that we might consider that hasn't really been done is that do big, large-scale restorations efforts like this require socioeconomic mitigation? And would we actually accelerate the process by offering socioeconomic mitigation prior to permitting? On the institutional side, the one everybody brings up, of course, is permitting. This is a spaghetti diagram that the American general contractors have put together. And I don't know if you can read the tagline, but it says, "So you want to build? Good luck with that." And it speculates the thousands of days of permitting time. Now, they do identify some places that they think there's duplication, but in all honesty, the big problem is the number of laws that have to be considered. And that creates its own set of problems, right? Which laws do we do away with? Would you prefer to not deal with CERCLA that deals with hazardous waste? Or maybe in your case, the Endangered Species Act isn't important, or maybe the Marine Mammal Protection Act, maybe the 408 program that seems to be a sticker, that's the one that says that a current project can't negatively impact a project that taxpayers have already funded in the past. So who decides which one of those laws is no longer important? A couple of other really interesting institutional constraints, I think, is we commonly hear that we can deal with these issues with adaptive management. But many times when we think of adaptive management, what we're really thinking about is adaptive operations. And adaptive management also includes things like who does the long-term monitoring? What is long-term? The Corps of Engineers, the federal requirement's only for 10 years. 10 years of monitoring doesn't count for much in diversions into an estuary this size. Who decides what the goals and the criteria are? Who enforces it? And I think there's a whole new level of definition of adaptive management that will ultimately need to be defined and funded for projects like this. And then another interesting component that I think is kind of philosophical in nature but cuts across restoration projects around the country is a redefinition of ecological baseline. And what I mean by that is that the custom now is that you predict or you compare with project situation to current conditions without project. Okay, but if you're around South Louisiana a good bit, what you'll hear is, well, we want to compare what will happen compared to what would be out there for 50 years. We want to compare it against the future condition. So the result of our project may not be much different than it is today, but it's better than what it's going to be in 50 years. That's a subtle but very different paradigm that has some interesting implications. So for example, I put a picture of the Cape Sable seaside sparrow. That's one of the endangered species in the Everglades. It's very susceptible to water levels. And following that, the reverse side could say, well, 50 years from now, the Everglades are going to be completely wet, so the habitat's going to be gone, so why are we spending money protecting this seaside sparrow now? 50 years from now, that road's going to be underwater, so why fill the potholes and maintain it today? So there's a new paradigm, a new way of thinking that probably has to be adapted. In Len Chauvin's report, there was a statement that I thought was really interesting. It says, we do not believe that the standard processes can effectively define and make these trade-offs, in large part because the advocate's vision that includes replacing a current and degrading ecosystem with a different one has not been explicitly accepted by either the Corps or the federal resource agencies. Nor, would I add, has it been accepted by a significant proportion of the general public. And so that is a really critical change in the way that we need to think and the way that we'll have to progress in order to make some of these projects get successfully through the permitting process and through the construction. Because essentially what we're trying to say is that we know enough about the future to predict what's going to happen if we don't do anything. And we also say we know enough about bioengineering to successfully create an ecosystem that's better off than what will be there. And those are significant differences from the way we currently do business. Thank you.
If anyone has any questions.
John. You talked about increasing water levels with diversion, but the Chapter Black Snake system has run for a long time and has very high water levels at the riverside. It's the most safest place in the coast, all the way down through the salt. So I mean, increased water levels is not always bad.
It may not be, but in fact, the Wax Lake, you know, they discharged since 1943, and it was about 30 years before, you know, the deposition was able to compensate sufficiently to get above the water surface elevation. And so it could be that in the long run, the water levels are, you know, the degradation or the aggradation offsets the water levels, but it may not happen immediately. Thank you.
Thank you. All right, our next speaker is Matt Bethel. Matt's the Executive Director of Research at Louisiana Sea Grant.
Okay, great. Thanks, Scott. It's great to be here with you. Welcome, everyone. Today I'm going to talk about a research project that I've been working on for the past few years as part of a multidisciplinary research team in collaboration with local community partners. And the purpose of this work is to enhance coastal hazard mitigation planning, local coastal hazard mitigation planning, by incorporating the traditional ecological knowledge of the community partners in the process. So some of you may not be familiar with traditional ecological knowledge. Basically what it is the observational knowledge gained from people who have lived in an environment most of their lives, if not all of their lives. It's usually intergenerational knowledge that's passed down through the generation in a community that is intricately tied to the surrounding coastal ecosystems. And you know, Bren referred to earlier in his presentation that Louisiana is essentially a working coast. And that's true, and we have a lot of people on the coast who possess this traditional ecological knowledge that can be very useful in coastal restoration, protection planning, as well as local hazard mitigation planning. And through this process we've developed you know, in partnership with the local collaborators and working with many different communities, you know, basically you might say, well, why, what's the benefit of incorporating traditional ecological knowledge into the current state level, local level planning process? And, you know, I've listed a few benefits here. There are many benefits to doing so, but a few of the outstanding benefits I've listed: contributes new knowledge from years of on-the-ground observations to the process, get you in the engagement process to access the traditional ecological knowledge. You gain support for projects from local experts in their communities because they feel empowered and they're part of the process, as long as you utilize that knowledge in a meaningful way. There's also opportunity through that engagement process for reciprocal knowledge transfer. So in this work, we're not just collecting traditional ecological knowledge from the community participants, we're also taking the opportunity to share science, answer a lot of questions that they may have about the current restoration and protection planning from a science standpoint. And also augment the current planning and implementation process. The whole purpose, and this is a key point to consider, the whole purpose of this work is not to replace the existing planning process that is science-based largely, but it's complementary information that can be included in the process to enhance the outcome. So this is just, you know, I won't belabor this map. It's a coastal land loss situation in Louisiana. And you can see, let's see, where's the pointers? Oh, okay. So you can see we're here in New Orleans, and I just throw this up here for a point of reference because where I've worked in communities, you know, across southeast Louisiana and Barataria Basin, some of these hot spots of land loss, which is a predominant issue among these communities. For the purposes of this presentation, I'm going to focus on some current work that is ongoing with the research team with the Pointe-aux-Chênes tribe located in South Terrebonne Parish, Louisiana, and it is a hot spot of land loss as indicated by the square. Zooming in to that area, you see the land loss map from this community's experience from the 1930s all the way to 2010. The community is located right here, the tribe, the Pointe-aux-Chênes tribe along this finger of the Pointe-aux-Chênes Bayou. And this is their ecosystem-dependent livelihood base. So the methods that we developed and the approaches that we use are to work with each community on an individual basis, identify key, what we refer to as TEK experts within that community. TEK experts meaning those who are most respected for their knowledge of the ecosystem within the community. And in this particular instance, working with the tribe, we went through the tribal council to then they make references on who we should work with in the tribe. And so the first part of this is to get to know the TEK experts, go out with them, the research team consisting of me, my background is geography, remote sensing, and GIS. But throughout this research, I've partnered, like I mentioned, on a multidisciplinary team with social scientists from UNO CHART, Center for Hazards Assessment Responsive Technology. And so what we would do is go out with the TEK experts on trips. We would not set the agenda. We wanted to hear their perspectives on what is most important from their viewpoint to show us related to, for this specific project, it was sea level rise hazard mitigation. So vulnerability, perceived vulnerability to sea level rise and storm surges. So part of that process and the data collection that we use in this process, you know, the social scientists are recording the conversations that we're having out on the boat, while I have a mobile GIS unit and I'm recording the routes that they take us. Each individual trip is unique, but there are similarities, and that's what we want to get at. As you can see here, I've overlaid several trip routes that the TEK experts have taken us on and indicated sites of interest by the dots. Different colors represent a different TEK expert. And they were taking us to these sites to illustrate points that they were trying to make about their vulnerability related to sea level rise and storm surge. And what we do in the analysis of this information, you know, the social scientists, they're doing the qualitative data analysis. We transcribe all of the conversations that we have out in the boats. And they do coding analysis to determine what themes are emerging that are common among the TEK experts. And I'm doing the same thing with the spatial data sets. I'm looking for areas such as I pointed here in the red arrows, where the TEK experts have taken us to similar locations to illustrate similar points they were trying to make. And I'm going to go through an example here just to kind of illustrate the process that we use. And keep in mind, this is all for the tribe's hazard mitigation planning purposes. All of this information that we're developing is for use locally by the tribe in enhancing their mitigation planning. So here you see, you know, we go out in the boat, that's the boat there, and for this particular area, you know, this trip, we had our drone with us, and so we were able to get this nice perspective for you here. And the reason he was taking us to this area, this fisherman, was because he wanted to illustrate the point that, you know, there's a vast network of canals, oil canals, that were cut in the marshes between Pointe-au-Chien and the open waters of the Gulf over the last several decades. And some of those canals, for whatever reason, have eroded a lot and expanded over that time, and contributed to a lot of the marsh degradation there that allows, it's just like highways for storm surge right up into the marshes that once protected this community, as well as allow saltwater intrusion up into these areas that were more fresher marshes at one time, causing a lot of changes. So he took us to this point to illustrate the idea that he was trying to get across. But not only he, but other TEK experts were taking us to similar locations to illustrate the same points. And so through that process, we're able to weight these location factors, and what we call location factors. And for vulnerability, that became one of our predominant ones. And the way we're able to weight it is from how many different TEK experts are referring to the same idea, and what emphasis did each expert place throughout the trip they were taking us on that idea. This emerged as the highest weighted factor. And what we do with it, you see the quote here, so this is pulled directly from the transcripts for this TEK expert. See this right here, this should all be solid land, all them cut canals. That would be sort of a buffer that would stop the water from getting up there so quick. So translating that, that's our purpose into this factor. We translated that and other quotes like that into an overarching factor. Canals cut in marsh that have widened from erosion contribute significantly to community vulnerability to sea level rise and exacerbated storm surge. So what we're doing is trying to provide these mapping products to the tribe. So I'm thinking, how can I map that factor? So what do I need to do that from a GIS remote sensing standpoint? I need a land loss data set from USGS, I can get that, check. I need a LiDAR elevation data set, I can get that, check. Also need an oil canal network data set. We didn't have that at the time, so we developed our own from historical satellite imagery and aerial imagery of the study site. And you can see in the white, that's what we mapped as from that remotely sensed imagery is oil canals. We had more, and we went back with the community TEK experts to go out with them and verify. So we did an accuracy assessment on this until we got what you see here. Now what we're able to do with this one layer, and this is an example here, is we're able to do analyses like this where we do proximal land loss density next to these canals to get kind of an idea of where the land loss is, what canals are contributing most to that land loss. And we also measured the widening of these canals at different locations along each canal to see which have widened the most. So basically what we hope to do with this map and where we're going with it is we're going to have a relative classification of the canals in this area from contributing most to the community vulnerability, perceived vulnerability, to the least. Another interesting thing, and this is an example of another factor, is that while the oil canals did contribute to their vulnerability, another factor that is emerging from the data analysis is that, okay, there is a sustainability factor that canal spoil banks contribute, sort of like speed bumps. The community perceives them as speed bumps to oncoming storm surge to help slow that down and attenuate waves as it approaches the community. Now, if you think about, if you're not familiar with the spoil banks, think about it when the companies dredge these canals, they throw the dirt up on the banks, and that creates a higher elevation, and trees and shrubs grow on top of that. And so that's a lot of times in this area, the study area is the highest elevation in the area. So what we did was we created a sustainability factor. Spoil banks of canals cut in marsh offer potential protection that can contribute to community sustainability to sea level rise and exacerbated storm surge. And we've got quotes like I've mentioned before, thinking about the data sets, okay, how can I represent this factor? And I'm zoomed in on one area where it's a dense network of canals in the study area, and what we did was map the density of the spoil bank as a function of width of the spoil bank and height of the spoil bank. They're not all the same height because subsidence, some of the spoil banks subside, some of them erode away, but there are still some that are pretty high. Now you see here, this map represents everything half a meter or more in this zoomed in portion with a lot of canals. And you can see as storms would approach storm surges from the south to the community that might help slow the storm surge or dampen the wave attenuation, or contribute to that. But if you go up, and this is real important for the community to see and to visualize, if you go up to 1 meter or greater, the capacity of those spoil banks to attenuate the storm surge becomes drastically less. And if we go to 2 meters, you can see even more so. And so this is really important when the community is considering hazard mitigation to projected sea level rise scenarios that would exacerbate storm surges. So what we do, this is an iterative process. As we're developing these maps, as we're coding this information to develop these themes, we're going back to the community and we're verifying where we're going, making sure we're on the right direction, making sure we didn't miss any information, and this gives the community collaborators an opportunity to provide feedback to the process from the beginning to the end product. And the final part of this is to have these host data visualization workshops in the community. And you know, these are where we use interactive tools to overlay these layers, show how different sea level rise scenarios will impact those vulnerability or sustainability factors, and let the community have these products so that they can, you know, they're actively looking for resources to protect their tribal lands. And, you know, we hope that this information will be useful for them in prioritizing where those limited resources can be best distributed. And with that, I'll take any questions. Thank you.
All right, any questions? All right, then we'll move on. Diane.
Right, so that would be, so what they're doing is trying to get resources to help them make better decisions. And part of that process would be to use this information to then present to funding sources, work with CPRA. We went with the community, met with Bren at CPRA a couple of weeks ago to discuss ways that they can leverage the state master plan projects to build and develop projects that directly relate to their specific priorities. And so hopefully this information they use to then determine where they should best apply those resources as they're able to obtain them. Yes?
Looking at resources, does the tribe ever consider going back to the industries that dredge these canals to get some compensation?
Yeah, that's a good question, and so what they're doing. So this tribe is state recognized. They're applying for federal recognition. They've been applying for federal recognition for the past few decades. They're getting a lot closer to getting there, and that's one of their major priorities, is to gain federal recognition so that they can then protect those tribal lands more and you know, they're looking to gain compensation and to gain the oil companies' involvement in maintaining that place and keeping it secure. And that step to gaining federal recognition will greatly enhance that process, that they're looking to engage the oil companies that dredge those. Right now, they would love that, but the oil companies aren't stepping forward to do anything about that. Well, that is a good question, and you know, this federal recognition process has been going on for 30 years, and it changes you know, they get close, and then the goalposts change as different administrations come in, and they have different sets of criteria they put in place. So they're always having to adapt and change to meet those criteria. And the hope is now that they're getting close enough that, you know, that they're closer than they ever have been, they feel like now. But there's complicating factors. They're not the only tribe, state recognized tribe, that are moving toward federal recognition in that process. There are other neighboring tribes that are doing the same thing, sometimes claiming the same tribal lands, so that complicates the process a little bit.
All right. Thank you, Matt.
Thank you.
And last but certainly not least, I'd like to introduce Diane Austin. Diane's a research anthropologist and the director of the School of Anthropology at the University of Arizona.
Thank you, and thanks to those of you who are still here. You're probably wondering, first of all, what the fishermen, when we first started working in this area in the 1990s, asked is, what are you people from Arizona doing here? You don't even have any water. Well, we don't have a lot of it, but so I'm going to actually start off with a little bit to give you some background on what I am doing here. I've worked in southern Louisiana and the coastal region for about 20 years, mainly looking at the social effects of the offshore oil and gas industry on this region. And so this is work that we've done in that area, but most specifically to this panel, have served on the Technical Advisory Committee on Resiliency for the 2017 Coastal Master Plan. So we've heard a lot about the challenges facing the coast, and what I was asked to do was to put some people on this landscape, and Matt's given us a good start at that. And so just a little bit about methods, because I'm not sure how many people are familiar with what we do. This is ethnography as our primary research approach, and involves the methods you've seen here, which is really embedding ourselves into communities for long periods of time, and really placing the phenomena that we observe in the historical, social, economic, and political context. In addition, a method that we've used for, we actually have over 700 oral histories now, is oral history. And this is a region where, for a number of different reasons, low rates of literacy, documents get destroyed in storms often, and people just not recording a lot of the history. Oral history is a very good way to try get at and understand history. Here are some examples of quotes from some photo interviews we did. We have over 1,000 photos that people have donated to the collection as well. So moving forward with that as a background, the Louisiana coast, as we know, is long and complex and dotted with hundreds of small communities. So what I'm going to do today is, and similar to what Matt did, is focus in on a particular area and let us look through their eyes at both some of the maps and some of the processes that are going on. So I've got New Orleans marked up there in the corner. That's where we are. If you head south, we're a little bit to the west of what the area Matt was talking about, in Terrebonne Parish, to the communities of Dulac and Bobtown. Elevation 3 feet. So let's look at these maps that we've been looking at now from the perspective of the people in that area. They're living in an area, as you can see, that's very much red and undergoing land loss. They're living in an area that's looking at, as you can see, from 13 to over 15 feet of flood depths. And they're living in an area that's had already some work done, primarily hydrologic restoration and some shoreline protection. You will see on here these purple lines, and I'll talk more about that later. Those are levees. And you'll notice this levee goes only part way, and we'll talk a little bit about why. So, who lives here? Across southern Louisiana, there are communities of people, many of whose ancestors were pushed or brought into this region. Now, we have evidence of human occupation that goes back 14,000 years. This map shows the groups that were living in the southeast at the time of European contact. Now, the Native Americans in what is now Terrebonne Parish were actually an outcome of European Western expansion that disrupted Native communities across the southeast and drove people into outposts such as southern Louisiana. And you'll find this across the globe when you move into lands that are deemed marginal by societies. Often people are there because they were pushed there for various reasons. So here's a little bit of history as to when the folks that are now in this region arrived there. Now, one thing to remember is the groups that are identified as tribes today were not tribes before white contact. We generally we being European settlers and the US government, gave them designations as tribes, and so they're not always coherent by the way that people identify themselves. And this becomes important. You'll hear more about that in a minute. Now, in the 1700s, we also had another group of people, the Acadians, or the Cajuns, who arrived, having been pushed out of Nova Scotia and France. And this is an aerial photo of another community, Grand Bois, Louisiana, that shows how the settlement patterns of the Cajuns are still very evident on the landscape. They settled their long linear communities using the French arpent system. And so from the 1800s on, there are records of people of Chitimacha and Houma descent who were trying to acquire land and in some cases successful, in Terrebonne Parish. But then what also happened in the 1800s was the plantation economy moved south. And at that time, primarily sugar, led to the rapid importation of slaves and resulted in a population of Terrebonne Parish that actually became black by a ratio of 3 to 2. By 1853, Louisiana's sugar plantations were producing a quarter of the sugar for the world, and the slaveholders were some of the wealthiest in the world. So in 1864, Louisiana abolished slavery. In 1866, freedmen were allowed to acquire land. So here's an example, Bobtown, the community I showed you I would talk about as a case study. Following emancipation, many blacks fled north from the south. However, many stayed. And this community of Bobtown is an example. In 1898, Robert Celestine, who was a 25-year-old of African and Native American descent, he and his father-in-law purchased land that was actually a former plantation. And Bob and his wife had 12 children. They divided the land among their children. Their children continued to divide and occupy the land. And today there are about 25 homes remaining in this community. Now, prior to 1900, In the US Census, American Indians were not distinguished in this area from blacks and whites. There were only two categories of people. Due to the Jim Crow laws and the practices in the South especially, many Native Americans who were able to pass as white did so. And so, but locally, people were very aware of who was Native American, who was or Indian, American Indian, who was white and who was black. And the term, the derogatory term that others used for the Native Americans was sub-in. And as you see from a quote here, some work we did early on, that was considered the lowest category oftentimes. They were denied access to white schools and to other places. Now, a key factor in the population changes were the extractive industries of the region. I talked about sugar, there were also cypress timbering. The industry in the region I'm talking about peaked around 1914. And then we have large populations of shrimp discovered to build up a shrimping industry as well. And then in the late 1920s, oil exploration moves into Terrebonne Parish. You can see here in Dulac, specifically it was 1936 when the Falk Oil Company constructed not only the first oil well, but as we've seen the maps, the first oil canal. Also in the 1930s, because there were schools only for blacks and whites, churches, especially the Methodists and the Baptists, started establishing churches for Indian children. And here's an example at Dulac in 1913. Miss Hooper started the Dulac Indian Mission, which continues today as the Dulac Community Center. So, post-World War II, this question, a great question about what are we going to do about the pipeline canals. First of all, the pace of oil and gas industry accelerated with really limited opportunities for locals. You had to speak English, and African Americans and Native Americans were not allowed to work in the industry. Still, those who did own land were approached for right-of-ways, and I think this says it all right here, for the purchase of $5. For $5, the Texas Pipeline Company purchased essentially permanent right-of-way access across people's land. Did they anticipate the kind of erosion? Of course not. As to what was coming, did they have much choice? You could argue they didn't have much of that either. This agreement was, quote, signed by a gentleman neither he nor his son could read or write. So, another factor, hurricanes. Hurricanes have long been a factor in southern Louisiana. I put up here from 1964 on in Dulac. That was really the time when the hurricanes started having such an effect. And again, you look at what we've looked at in terms of land loss, in terms of this regular flooding. And 1985 was huge for this community because by the time Juan hit this area, it had been downgraded to a tropical storm. But it already was having such impact at the community at that time and then ever since, and now it doesn't take much of a storm for people to be flooded. So, as the oil and gas industry expanded, labor was needed, and we started to see the involvement of other peoples into the oil and gas industry. Blacks were allowed to start working in the shipyards in the 1960s. People in the Dulac area, Native Americans, who started into the oil and gas industry and began working in the 1970s. So a little bit more back to the social side, 1960s and 70s was also the era of the civil rights movement. And it's important to note that one of the lawsuits that was settled in New Orleans in federal court was a suit that originated in Terrebonne Parish, again allowing American Indians children into white schools. And so that was ruled. And so what you see here is, although the Chitimacha tribe first was federally recognized in 1917 and was granted a reservation, the other tribes, there are only 4 federally recognized tribes in Louisiana, and they're shown here. You see that it's the 1970s and 80s. In 1977, 2 groups, the Homa tribe and the Homa Alliance, were recognized by the state of Louisiana as Indian communities. They formed together to form the United Homa Nation, and that was then and that group was recognized as an Indian community in 1990. They filed for federal recognition in 1985, and that petition was denied in 1994. Following that denial, two other groups, we've heard about one, the Pointe-au-Chien tribe, and the Biloxi-Chitimacha Confederation of Muskogees, began organizing and filing for federal recognition. And in 2004, the Louisiana legislature acknowledged the Indian ancestry of the individuals who are members of those groups. The point of all this being, like everything else we've heard today, I think complexity is the name of the game. So what is going on here, while all of these social political dynamics are happening, land loss continues, but people are trying to respond. I put this up here because to the far right, that's actually Lafourche Parish to the east of Terrebonne, and you can see they are surrounded by a levee. There is a lot of different reasons why Terrebonne Parish is not surrounded by a levee. Some of it being it's a very different topography and trying to put a levee, and also some of it being political, where to put the levee. The levee that's shown on here, and you'll notice, does incorporate Dulac. One of the earlier proposals did not. And the Methodist Church actually became involved in helping to advocate for the people there, and the path of the levee was changed. So, meanwhile, again, land loss continues. Here is Dulac. It's a little hard to see on there, that says Dulac. So you can see here, just 17 years, how much land loss is taking place right here in these communities. This is a map we created with the people, much similar as Matt was talking, in terms of creating with people what's happening, who's moving, and how are people responding. People are responding to this land loss in the same ways the Coastal Master Plan envisions. And that is, some people are flood-proofing, some people are raising their homes, and as you can see, people are moving. What I want you to notice, and oh, it got cut off, so I'm going to tell you, is the rates are not the same. Overall, between 2000 and 2010, 40% of the population of Dulac has left. Of that, the white percentage is 47%, American Indian 36%, African American 54%, Asian 8%, and then the two or more actually goes up, and I believe that's because people have a choice of identifying themselves on a census, and people may have at that point, because many people are of mixed heritage, actually identified themselves with more than one group. So, but the issue about leaving, as you can see, one of the things that happens when this many people leave a community is you start to lose your schools, you lose your churches, you lose your library, the stores close down. And so, but leaving is hard. Leaving is hard not only for the reasons that I've talked about, the historical, social, and cultural ties that people have to these places, but also because their livelihoods are very much tied to the coast. In these communities, you have people who still work in the oil and gas industry, people who work in the fishing industry, as well as people that are working at the shrimp sheds and otherwise. So, how does all of this factor into the coastal management plan? Well, we've heard about the structural protection, which are the levees, seawalls, etc. And we heard about the non-structural protection or options and projects that I told you about. So the question really about voluntary acquisition is, once enough people move, is it really voluntary anymore if your community doesn't exist? And so fundamental to this process has been, and as we've heard about, who makes the decisions, who gets to weigh in. This is a quote from the Coastal Master Plan that clearly, as people across this region will say, this is our home, how do we protect it? But again, who then is getting involved? And based on what I've told you so far, imagine you can expect, I expect you will imagine that trust is not real high among some of these populations. So as we look at the maps, I would just argue that we should always remember that across this landscape are many, many people, their families, and their communities. The region accompanied by these maps is replete with stories of struggle, but also stories of triumph. My parting words would be: place matters, history matters. And hopefully the challenge that we face, everybody faces who's trying to address this here and elsewhere in the world as we forge ahead, is to respect the past, to address and deal with the complexities of the present, and to look ahead to a better future. Thank you.
So I know we're out of time, but all of the speakers will be here, so if anyone has questions or wants to come up, feel free. And I'd like to thank you all for coming. And
if I may, I'm Steve Burgess. I'm a retired civil engineering professor from University of Washington. I've been coming to AGU meetings, having missed 2 in the last 46 years. My thanks to you as conveners for putting together one of the most valuable sessions I have ever attended, and my thanks to every speaker for an excellent presentation, and every member of the union should have been here to hear what you had to say. Thank you all very, very much.
We're glad that was on tape.
Do we have time for one more?
Yes.
Sure. For the last presenter, I'd be curious to know, so there's voluntary out-migration, but there's also, I understand, plans to do organized resettlement in some of these coastal communities. And could you just speak to the relative pros and cons of the voluntary out-migration? Are people actually moving en masse to certain other locations, or are they just going to urban areas and essentially dissolving? Is this whole way of life being lost? Or are there ways through perhaps organized resettlement to move people to areas where they could actually continue to pursue the kinds of livelihoods and traditions that they've had for centuries?
Sure.
Thank you.
Great question. Actually, all of that is going on. One of the earlier speakers mentioned that there is actually, the state of Louisiana has received a grant from the U.S. government, Housing and Urban Development, to do a planned relocation of people from another area in Terrebonne Parish, Ile-de-Jean-Charles, which is another mixed community that has people from various groups still living there. One of the challenges that you face in any of decisions to relocate people is that people have been leaving for years now, and the question of where they're going, part of the question of who's leaving and who's not, it has to do with resources. Who can afford to leave? Can you acquire something? Where are your social networks? One of the things that all of us who are fairly mobile, I'm guilty of that, I've lived in many places in my life, I've had the privilege of going off to school in different places, is we often forget that for folks who have limited economic resources, those social ties, we have very good examples in the US, the Pruitt-Igoe housing developments in Chicago, of where we raise communities and build new communities, hopefully to help people, that when you disrupt those social networks, you cause a lot of heartache. So there are efforts now with the community of Ile-de-Jean-Charles, with the various people that live there, by the state to try and understand who those people are, who are they connected to. Do you give people an option of going to, you give them money and let them choose where they want to go because they may have family networks somewhere else? Or do you try to move everybody at once? Did everybody want to live together forever? When you look again, especially in situations like this where you have out-migration happening, the people who are left for a multitude of reasons. Some people taking care of elderly parents, a lot of different things. And so who is going to want to move and where are they going to move? I mean, you look at the livelihoods of people along the coast, can you find that, can you access that inland? And if not, what kind of mechanisms? Do people have transportation? Do they shop at the grocery store, or are they relying on fish and crabs and things that they're catching? And therefore, how do you make up for that if they don't have an income? Post-Deepwater Horizon, we saw huge issues around this from the folks trying to do the settlements, not taking into account how much of the economy of South Louisiana is still not a cash. It may be a cash economy, it's not a W-2 form. How do I even compensate you for loss? So all of those become factors. I know this is a really long answer, but it is very complicated. And the first step is just recognizing how very complicated it is.
I have a question for you as well, please. Do you happen to have data on the ages of the people that are leaving? So for instance, 25% or 30% of a certain group are leaving. Well, if that is 100% of everyone that's under the age of 40, then you no longer have a community in X amount of years. So could you please speak to that?
I will, and actually we're just getting ready to move into another study. The data you saw, the trick we have is, of course, the census has changed in this process, so even using census data is tricky. We haven't gotten to 2020 yet. But what you see oftentimes, and what I will say this is not a quantitative data, but from the people I know in those communities, often you have people with young children who want their children in the community with their grandparents. We are seeing more people who have young school-age children moving up because the schools have closed. So it is a long bus ride from the lower bayous all the way up to Houma to go to school. So you're seeing some families moving up. Again, the map that I showed that had the arrows kind of jumping around, there's a large trailer park in southern Houma that has become the site at which a lot of people from the lower bayous have moved to. So they're not moving leapfrogging, which is another issue I think that gets into this bigger question of, as you relocate people, how far up do you go when you look at those maps? And it comes to the question I think that John was talking about is, how far out are we thinking? Where do you move people to? So right now, people with younger children, the older folks who are saying, I don't know any other lifestyle, this is my home, this is where I want to stay. The working population, a lot of if they work, again, if they're fishermen, they work, but what we're seeing, there used to be a shipyard in Dulac. That one is on the verge right now, I believe, of closing. Again, I haven't been there in a couple of years. Several of the shrimp sheds have shut down, so the employment opportunities are leaving. So you will see, but a lot of, unlike some communities where you would say all the workforce has left, because the work was still in that area, a lot of those folks were there. But definitely you would say now, for younger people coming back in, it's part of what's going on is the oil and gas industry is changing so dramatically as well, that people, young men especially, used to be able to get jobs even without a high school diploma. Nobody hires anybody without a high school diploma anymore in that industry. And even to work on the boats, the Coast Guard used to allow people who could not read. There were alternate approaches to getting licenses. All of those things have changed. Even towboat captains now are falling under more regulation. So all of that reduces the options that people have. So those social changes are also taking place, which are driving people north. Okay.
I think we should probably, if we have additional questions, I'd encourage people to come up and meet with the speakers, but we may need to vacate the room in a few minutes. So I'd like to thank everyone once again. Great session.